Good evening, I'm Timon Bradley.
And I'm Jackie Bang. WGN's Emmy Victor is live on the lakefront with the latest. Emmy.
Jackie, a triple tragedy on the south side has left many people speechless. 3 bodies were recovered from the water.
Lake Michigan's glassy surface betrayed nothing, until suddenly, odd tremors rippled across the water with no apparent origin. Without warning, the lake began acting unlike itself. Huge, eerie voids opened up on the lakebed like craterous holes where scientists expected nothing but smooth sediments. Temperatures in patches along the southern region of the lake spiked, forming bizarre rings of warm water that contrasted sharply with the adjoining chill. Above the water, rare fog banks rolled out of nowhere, hovering over the waves like specters. All of it happened in concert, fast and with no clear trigger. People watching the shorelines and marine researchers alike knew something strange was unfolding. Before we start, please don't forget to like and subscribe to our channel for more updates. It started with the sonar scans. Teams mapping the lake floor for routine ecological and geological monitoring began to notice depressions, deep, perfectly circular hollows hundreds of feet across. These were not random troughs or ravines carved by ancient glacial activity. They appeared fresh, abrupt, and oddly symmetrical. The scale was startling. Some measured 600 feet across, others smaller but still unnerving in their regularity. Underwater cameras confirmed that the openings plunged into darkness, the edges sharp and clean, as though something had punched through from beneath. At nearly the same time, satellite thermal imagery flagged an anomalous ring of warm water in southern Lake Michigan. Amid a backdrop of steadily cooling temperatures migrating outward from the shore, this ring stood out. Its interior was 10 degrees warmer than the surroundings. The anomaly defied the usual patterns of solar heating or simple wind-blown currents. It appeared almost as a thermal bubble, an isolated hotspot in the depths. Meteorologists and lake scientists looked at wind maps and pressure systems and found that the area beneath the curious ring had experienced near-still air, a rare pocket of calm that allowed the water surface to heat unusually. Yet that hardly explained the abruptness or the intensity of the temperature differential. Then came the fog. One evening, a ghost-like white bank rolled over the lake's surface, creeping inland towards shoreline towns. It appeared in patches, thick and dense, lingering over some stretches of water and skipping others. Locals reported that the fog seemed to drain away when they shone cameras or lights into it, but reformed behind them. It was subtle, unsettling, and unaccountably precise. Possible explanations like temperature inversion or moisture layering were considered, but the fog's behavior refused to match standard models. These layers of weird activity, bedrock craters, isolated heat, phantom fog, didn't just occur separately, they seemed to cluster, overlapping in space and time. The same sectors of the lake where the underwater voids were forming overlapped partially with the thermal ring's border. The fog drifted over those same corridors. It was as if a force or disturbance was pulling together phenomena that ordinarily had no reason to cooperate. One cannot ignore the lore of the so-called Lake Michigan Triangle, a region bounded roughly by points around Ludington, Manitowoc, and Benton Harbor, famous for mysterious disappearances of ships and inexplicable navigational errors over the decades. In that folklore, compasses misbehave, vessels vanish without distress signals, and strange lights flicker out of the depths. The new anomalies seem to echo those old legends in eerily molecular detail. Could whatever force lies behind these current events be tied to deeper geological or magnetic instabilities beneath the lake's crust? From a geologic perspective, the sudden sinkhole events suggest abrupt movements in the substrate, perhaps gas pockets or trapped methane locked under pressure, suddenly released. You could imagine subterranean cavities eroding or collapsing, letting overlying pressure fall away and causing material above to slump violently. Such collapse could explain the sharp edges of the holes in their fresh formation. But for that to happen at these sizes and depths, and to align so well with thermal and surface anomalies, is to propose a system far more dynamic than previously believed. The heat ring poses a different enigma. Typically, thermal anomalies in lakes come from solar heating, inflows of warmer water, or gusts stirring warmer bottom layers upward. But none of those seem adequate here. Wind was nearly calm. There was no known inflow of warm water from rivers or underwater springs at those spots. Instead, the lake seems to be self-generating pockets of warmth. That suggests either subsurface geothermal heating or chemical exothermic reactions, processes deeply hidden beneath the sediments. Could heat be leaking from volcanic fissures or deep faults beneath the Great Lakes Basin? Or could subterranean pressures and friction generate heat in localized zones? Then there's the fog. Fog forms when moisture-laden air cools until water droplets condense. It requires specific temperature and humidity gradients. But here, the fog seemed almost conjured. Lobes appeared in alignment with the thermal ring boundaries, as though the ring heated an above-air layer, triggering condensation precisely above warm-to-cold gradients. In effect, the lake might be breathing, warming from below, causing surface moisture to condense, creating fog patches that map exactly onto hidden thermal contours. That would mean the lake is acting as a bridge between the deep earth and the manifest weather above. Taken together, these phenomena hint at an integrated, multi-dimensional disturbance under Lake Michigan. The possibilities that leap to mind are distressing. At worst, this could be the early signatures of a tectonic or magmatic awakening beneath the Great Lakes region. While the upper Midwest is not known for active volcanoes, we do not fully understand the subterranean plumbing in this region. Perhaps ancient fault lines, stressed by climate change, glacial rebound, or groundwater shifts, are reactivating. If magma or superheated water is intruding upward, it might vaporize pockets of sediment, forcing collapse voids, thermal plumes, and fog generation above. Another unsettling possibility lies in gas hydrate disruption. In deep sediments, methane hydrates exist stably under specific pressure and temperature conditions. If something, baseline warming, pressure change, even seismic tremors, destabilize those hydrates, methane could release explosively. The escape of gas could carve craters, warm surrounding water through exothermic reactions, and flood the air above with moisture-laden plumes condensing into fog. Such a blowout might be sudden, violent, and unpredictable. Magnetic or electromagnetic effects must also be considered. The compass deviations historically reported in the Lake Michigan Triangle suggest local anomalies in the Earth's magnetic field. If subterranean iron-rich formations are shifting, or if currents of molten rock are migrating, they can distort geomagnetic lines. That might affect wayward compasses and navigation systems. In this current scenario, one could speculate that a localized magnetic flux shift is disturbing the lake's physical and chemical behavior, drawing water molecules, influencing currents, and even affecting meteorological patterns above. If this is indeed the precursor phase of a larger structural upheaval, the implications are alarming. The Great Lakes region supports tens of millions of people, a delicate freshwater ecosystem, and infrastructure built on centuries of relative geological stability. A sudden subterranean shift, thermal upwelling, or gas release could destabilize the lakebed, rupture pipelines, damage underwater cables, cause landslides on shorelines, and even spark sudden, unpredictable storms. We must also consider seismic triggers. An unexpected underwater quake, even minor, might initiate a cascade, fracturing the base, releasing gas, warming sediments, collapsing voids, sending shock waves that disturb thermal layering and stir fog. If the lake becomes a fault zone, we might begin seeing tremors propagate outward into bordering lands. Coastal towns might feel tremors previously unimaginable in an area not used to them. Compounding the danger is the speed with which all this appeared, without warning, as though the lake lies in wait for an instability to reach a tipping point. That means human observations will always lag the event. Early detection becomes critical. Monitoring systems, sonar grids, thermal imagers, seismic sensors, all would have to detect changes in real time. If we fail, we risk being blindsided. At the biological level, the lake's ecosystems could suffer irreparable harm. Sudden temperature changes and methane or other gas release can trigger massive fish kills. Oxygen levels could crash as heat destabilizes stratification layers and stirs deep waters. Sediment collapses can blanket underwater habitats, crushing benthic organisms. The collapse of one ecological niche sets off cascading impacts, from microorganisms to fish, to shoreline vegetation, to the human water users downstream. For navigation and shipping, the formation of giant underwater craters is a nightmare. Charts would become obsolete overnight. What once was smooth, safe passage becomes a minefield of unseen voids. Ships could suddenly lose buoyancy, drop into newly formed depressions, or be exposed to rising gas jets. Port infrastructure, piers, docks, intake pipes, could fail as supporting sediments shift. Insurance for marine operations might revert to prohibitive levels. Shipping across one of the world's busiest inland waterways could grind to a halt. And for human populations along the shores, there's a psychological and practical terror in waking to a lake that is no longer reliable. Beach towns count on predictable water levels, stability, clean water, and flood protection. If the foundation beneath the lake begins to shift, towns built decades ago may face coasts that erode faster, break apart, or collapse. Water treatment plants might be compromised. Flood defenses might fail when unexpected shifts displace sediments or alter flow paths. But perhaps the most unsettling implication is that this is no isolated event. It may be the signal of a broader continental shift. The Great Lakes cradle in North America, underlain by ancient continental bedrock, may be under stress from climate-induced mass redistribution. With glaciers long gone, water levels fluctuating, groundwater levels changing, and global warming altering thermal balance, ancient faults may be waking. If Lake Michigan is the first to show, then neighbors, Lake Superior, Huron, Ontario, might soon echo in response. This raises the chilling question: have we underestimated the geologic volatility beneath the world's great freshwater basins? We tend to regard them as stable, passive features. But what if the deep earth is nudging them, testing their limits? What if this moment marks the beginning of a new regime, where lakes ceaselessly breathe and shift beneath our feet? People who live along the lake are already uneasy. Amateur divers and fishermen reported odd currents, strange sonar blips, instruments behaving erratically. Some remote shoreline cameras caught flashes of light at depths where no activity should occur. A handful of drones flying over suspect patches recorded infrared anomalies, hot spots in water pockets where there should be none. Reports of low-frequency hums or subaquatic rumblings trickled into forums, though scientists caution about acoustic artifacts. Yet all those whispers now seem eerily synced with the larger anomalies. Bed craters, thermal rings, fog anomalies. No part of the lake seems immune. Northern reaches, deep basins, shallow shelves, they all show hints of change. The southern thermal ring isn't isolated. Weaker echoes appear elsewhere. The craters cluster but also scatter across membrane-like lines. The fog, while most visible in certain sections, occasionally creeps upward in unlikely stretches. The disturbance seems to be radiating outward, like a stone dropped into water, sending ripples across sectors previously considered stable. As I consider the event's trajectory, one chilling logic emerges. The anomaly may escalate. The number of craters could multiply. The thermal rings might expand, merge, or tear into one another. The fog patterns might complicate, densify, and spread inland. What begins as quiet subterranean stirring could surface into violent lake-wide disruptions. And once a threshold is crossed, the lake might never return to equilibrium. The stakes are immense. A sudden methane gas burst could create explosive hazards for boats. A thermal surge could fry habitats. A slip in sediments might collapse parts of the lakebed beneath high-traffic shipping channels. Alongshore infrastructure, sewage systems, intake pipes, foundations could buckle. The environmental and economic cost of a large-scale lake disturbance would rival a major earthquake or volcanic event. And because it began without warning, society may be ill-prepared. Monitoring systems across the Great Lakes region are robust, but not designed for such rapid, exotic anomalies. Models based on centuries of observation would struggle to adapt. Decision-makers may hesitate, unsure whether to evacuate, restrict navigation, or issue alerts. Meanwhile, the ground beneath the water quietly shifts. The night following the initial reports, a quiet unease spread along the coasts. The air itself felt heavier, laden with moisture that clung to skin and clothes. Local fishermen who had spent decades reading the moods of the lake said something felt off in their bones, an almost electric undercurrent humming just beneath the senses. The lake, once predictable in its stillness, had begun to feel alive, as if it were breathing in irregular gasps. Those who listened closely swore they could hear faint, low-pitched sounds reverberating through the water, like a slow heartbeat echoing from the depths. Scientists stationed along the shoreline began detecting subtle vibrations that did not correspond to any known seismic pattern. These tremors were rhythmic, yet oddly inconsistent. Their pulses neither fully natural nor artificial. Instruments recorded frequencies that dipped in and out of range, suggesting an intermittent energy source far below the lake bed. The possibility of geothermal activity deep under the basin, long dismissed as improbable, was reluctantly being reconsidered. The Great Lakes, carved by ice and shaped by erosion, were never thought to harbor such latent power. But now, as sensors blinked and readings fluctuated, the image of a dormant geological system reawakening grew harder to dismiss. Far beneath the surface, sediments that had lain undisturbed for millennia were beginning to shift. Core samples retrieved from the deeper sections revealed peculiar stratification patterns, thin layers of compacted silt alternating with bands of material infused with gas bubbles. It appeared that methane and other trapped gases were attempting to escape upward, fracturing the sediment in the process. Each release, however minor, could create a cascading effect, micro-collapse leading to a crater, crater leading to water displacement, and displacement triggering localized turbulence. The deeper researchers delved, the clearer it became that the lakebed was not static, but a complex living structure, one that could reorganize itself violently if its balance were disrupted. Amid this unfolding mystery, a curious atmospheric phenomenon began to manifest over the central expanse of the lake. At certain twilight hours, the horizon shimmered with a faint auroral glow. Though weaker than the northern lights, it pulsed with similar magnetically charged luminescence. Observers noted the light's eerie color, neither pure green nor violet, but an in-between hue that seemed to shift as it moved across the water. The shimmer would appear, linger for several minutes, and then vanish without trace. This glow corresponded almost perfectly with spikes in electromagnetic activity recorded by instruments on nearby monitoring buoys. Whatever was occurring beneath the lake appeared capable of affecting the air above, suggesting a coupling of Earth's internal energies with its atmospheric systems. The strange lights triggered a new wave of speculation. Some postulated that they were produced by piezoelectric reactions, light generated when crystals in the lake's rock strata were compressed by shifting tectonic stress. If true, it meant that powerful forces were accumulating beneath the surface, straining rock layers until they emitted faint energy discharges. Others believed the lights were plasma manifestations caused by methane venting into the atmosphere and igniting microscopically as it interacted with static fields. Whatever the origin, these luminous displays marked yet another sign that the equilibrium of Lake Michigan was unraveling. In coastal towns, wildlife began behaving in ways that defied explanation. Migratory birds veered off their usual flight paths, circling above the lake as if confused by invisible boundaries. Fish that typically thrived in deeper, cooler regions swam closer to shore, clustering in disoriented schools. Even the local gulls avoided certain sections of the coast, refusing to land where the fog and shimmering waters met. For biologists, it was an unsettling revelation that the disturbance might not be limited to geology alone. It was permeating the entire ecosystem. Animals sensitive to magnetic and chemical cues were responding to forces that human senses could barely register. The lake's currents, too, began to change. Mariners reported unpredictable flows that shifted direction without warning. Traditional current maps became unreliable as eddies formed in places that should have been calm. One research vessel attempting to navigate the affected zone described the sensation of being tugged sideways by invisible hands. Instruments confirmed sudden changes in water density, as though hot and cold layers were colliding in chaotic bursts. The water itself had become a dynamic battlefield between thermal forces, disrupting navigation and distorting sonar signals. As days passed, more of the lake's surface adopted a dull metallic sheen, reflecting the sky in unsettling hues. Chemical tests revealed slightly elevated concentrations of dissolved minerals and trace metals, implying that sediments from deep layers were being forced upward. The metallic glint wasn't pollution. It was the signature of the lake revealing its underbelly. This upwelling carried with it gases and minerals that had been sealed away since the last ice age. It was as if ancient Earth was reasserting its presence, rewriting the chemical identity of one of the largest freshwater bodies on the planet. The immediate human reaction oscillated between awe and fear. Some saw in it a natural wonder, the Earth speaking through its oldest waterway. Others saw the makings of a disaster, a slow and cryptic warning that the crust beneath the region was destabilizing. Rumors spread across social media that fault lines were forming, or that an underground reservoir of magma might be inching upward. These ideas, while speculative, were difficult to disprove entirely. Satellite readings showed subtle variations in gravity along the basin, hinting at density changes beneath the lake floor. Whether these were due to shifting sediments or deeper processes remained uncertain. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on Lake Michigan's sudden strange activity? We want to hear from you. Thank you for watching and see you next time.